Welcome to Maths with EJD. In this video, I'll be treating the question right before you. Two sets of numbers are given. S1, you have you have 2, 10, 8, 3, 8, 7, and S2 is 5, 6, 4, 6, 9. And we are told to find the means and standard deviation of the sets S1, S2. Then two, we have to find the mean and standard deviation of the combined set of the two sets. And then we have to explain type 1 and type 2 errors. That's why we are here. So let's move on. Okay, so the first part is A. So we basically want to find the mean of S1. Let's start with S1. S1 has 2, 10, 8, 3, and then 8, 7. So we want to find the mean of that. That will simply be, of course, we know mean already. Mean is equal to, well, we can call that X bar, and that is the same thing as the summation. It's the summation. Okay, since we are going to be looking for many means, let's do X1 here. So that summation of let me say, okay, let me say S1I, from I1 to the last one. There are six of them. So from I equals 1 to I equals 6. So that means you're going to have I11, I12, and so on and so forth. But that's simply the same thing. Okay, the summation of all this divided by n. So, and of course, we've seen, okay, so the summation of all this divided by n. So what this is going to mean is we have S11 plus S12 plus S13 plus S14 plus S15 plus S16. Okay. And then we know n is 6, right? But that's why we have up to X16. So X1 bar would simply be 2 plus 10 plus 8 plus 3 plus 8 plus 7 divided by 6. So X1 bar is equal to 12 plus 8, that's 20 plus 3, 23. 23 plus 3 is, 23 plus 7 is 30. So everything is 38, I think. Yeah, it's all 38. So we have 38 divided by 6. 38 divided by 6. Um, Okay, 38 divided by 6. Let me get a calculator to make things easy. So 38 divided by 6. And that is approximately 6.33. We may still use it in the fraction form later. That's 19 over 3 still. So we can have that. Then the next thing is to find the mean of S2. So to find the mean of S2, S2 is simply 5, 6, 4, 6, 9. 5, 6, 4, 6, 9. We want to find the mean of that. Again, we know that mean in this case would be X2 bar, which is summation of S2I from I equals 1 to, of course, N here is 5. We have 5 numbers there. So to 5. So we're going to have S21 plus S22 plus S23 plus S24 plus S25. Okay, so that X2 bar is equal to 5 plus 6 plus 4, 5 plus 6 plus 4 plus 6 plus 9 divided by 5. So that means X2 bar is equal to 5 plus 6 is 11. 11 plus 9 is 20 plus 10 in between. That's 30 divided by 5. So X2 bar is simply 6. X2 bar is simply 6, like that. Okay, so let's go for the standard deviation now. Standard deviation. Um, so I guess I want to change the pen. So to find the standard deviation, standard deviation. of S1, which is 2, 10, 8, 3, 8, 7. Okay. Want to find the standard deviation. Then we need to know that standard deviation is so let's call that, okay, let's maintain this. Let's call it SD. Let's call it SD1, and that will be the summation. I mean the square root of the summation of all the S S1I, if you like, minus S1 bar. Okay. Minus X1 bar rather, minus X1 bar divided by N minus one. N minus one because we don't have large data set. The data set is not up to 30. It's just 6 in this case, for instance. So we need the deviation of all these things. So we already have X1 bar to be, should we maintain the fraction or we can use the decimal? So let's use, okay, for the first time I want to maintain fraction. So this is to maintain fraction. What I mean is that I'm going to use X1 bar to be to the lowest common level. So 2 in 38 is 19, 2 in 6 is 3. So let me just use 19 over 3. So now X1 bar is 19 over 3. That's what I want to use here. And so that's 19 over 3 there. So it means that SD1, standard deviation 1, would simply be the square root of the summation of all the differences. So that will be 2 minus 19 over 3. Okay. Okay, I think that has to be squared. Yeah, we have to square this. So 2 over 19 minus 3 squared plus the next thing is 10 over 19 over 3 squared. Okay. Plus 8 minus 19 over 3 squared. Then plus, what do we have again? 387. So 3 minus 19 over 3 squared. Then 8. Okay, let me just do this. So plus 8 minus 19 over 3 squared. Then plus 7 minus 19 over 3 squared. So, okay. So this now divided by n minus 1. N already, we know that n, okay, that should be n1 here. N1 is actually 6 because you have 6 numbers. 1, 2, 3, 4, 5, 6. Okay, so here too I should have said, oh, okay, I didn't complete the number. So this should be over n1. So this should be over n1 also. So n1 is 5. Oh, so sorry, this should be n2. This should be n2. So this should be n2 divided by n2, and n2 here is 5. I didn't complete that. Then this should have been n1 divided by n1 also. So n1 is 6, like that. Okay, so here, still talking about SD1. So that's each of those things. 2 minus 19 over 3 squared plus 10 minus 19 over 3 squared plus 8 over minus 19 over 3 squared plus 3 minus 19 over 3 squared plus 8 minus 19 over 3 squared plus 7 minus 19 over 3 squared. All of that divided by, so this should be n1 minus 1. So that n1, so this is n1 is 6 here, 6 minus 1. So let's see how that goes. Let's see if we can just get that directly. The square root of, okay, I'm just going to do that top directly to save time. So get used to your calculator. I keep preaching that. That's really important. So we have 2 minus 19 divided by 3 raised to power 2 raised to power 2. Okay, so then plus the next is 10 minus 19 over 3 squared, 10. So the next is plus uh 8 minus 19 over 3 squared, then plus 3 minus 19 over 3 squared, then plus 8 minus 19 over 3 squared, plus this 7 minus 19 over 3 squared. Okay, so let's run over that again. 2 minus 19 over 3 squared plus 10 minus 19 over 3 squared plus 8 minus 19 over 3 squared plus 3 minus 19 over 3 squared plus 8 minus 19 over 3 squared plus 7. Okay, 7 is the last one. Yeah, you can see it's important to check because you can easily make mistakes here. So I go again. 2 minus 19 over 3 squared plus 10 minus 19 over 3 squared plus 8 minus 19 over 3 squared plus 3 minus 19 over 3 squared plus 8 minus 19 over 3 squared plus 7 minus 19 over 3 squared. So finally, what do we get? Okay. Finally, okay, we get something in decimal, which is 49.3333 divided by 5. So that SD1 is equal to square root of, that'll be square root of, okay, that'll be okay, in fact, it starts becoming an approximation here. Okay, it becomes an approximation starting from here. So we have 49.3333 divided by 5 equals 9.86666. And then we take the square root of that, and that will be approximately, square root of this is approximately, I think, 3 point something. I mean, 7 point something, actually. Yeah. I mean, 3 point something, sorry. So that will be 3.141. So that's the standard deviation for S1. Okay, so we can do the same for S2. So to find the standard deviation for S2, to find the standard deviation for S2, again, don't forget S2 has 5 numbers. So S2 has 5 numbers. So we do the same kind of thing. So for S2, which has numbers 5, 6, 4, 6, 9, 5, 6, 4, 6, 9. Then we can say SD2 is equal to square root of summation from, okay, summation of all S2I minus X2 bar divided by, okay, divided by n minus 1. So here that will be n2 minus 1. And of course, this simply means that n2, we know n2 is 5 in this case because there are 5 numbers, 5, 6, 4, 6, 9. And then we already have x2 bar to be, I think, 6. Yeah, I remember, I think x2 bar is 6. Yeah, x2 bar is 6. Okay, so then with this, we can go on. So we can now have SD2 equals square roots of, so the 5 numbers now. So 5, that'll be 5 minus 6 squared plus 6 minus 6 squared. That looks lovely. 6 minus 6 squared, that's already 0. Then next we have 4 minus 6 squared plus the next is 6 minus 6 squared again. Okay, plus what now? 9 minus 6 squared. Okay, this one is more straightforward than the previous one because it's just straight as n is 5, so we have 5 minus 1. So let's check again. 5 minus 6 squared plus 6 minus 6 squared plus 4 minus 6 squared plus 6 minus 6 squared plus 9 minus 6 squared. So without even using calculator, we can proceed, I believe. So this is square root of so 6 minus 6 squared is already 0. 6 minus 6 squared is also 0. So, okay, well, let's even go step by step. Um, Now I can flex my muscle because I don't have to stress with calculator too much. So that's minus 1 squared plus 0 squared plus minus 2 squared. That's 4 minus 6 is minus 2. 6 minus 6 squared is 0 again squared. 9 minus 6 is 3 squared. This divided by 5. Okay, well, I can just say 4 straight, right? This is just 4. And then ST2, standard deviation 2, is square root of, okay, I don't think it has to be this big. Okay, but whatever. So that's minus 1 squared is minus 1 times minus 1. That's 1 plus 0 plus 4 plus 0 plus 9 divided by 4. So that ST2 is equal to square root of 1 plus 4 is 5. 5 plus 4, 5 plus 9 is 14. 14 divided by 4. So we have ST2 to be square root of 7 over 2. That's square root of 3.5. So that's the second standard deviation. Square root of 3.5. That's definitely 1 point something. So let's do the square root of 3.5. 3.5. Okay, that's 1.87. 1.87. And that is the second standard deviation. So we have just finished the A part of the question. The Roman figure 1 part of the A question. So the Roman figure 2 part is to find the mean and standard deviation of the combined set of the two sets. Okay. Um, so that is A2 now. Okay. A2 says to find the mean. Let's start with the mean first. To find the mean of the combined set of the two sets S1, S2. Okay, that's what we want to do next. Well, we can actually go over again and start doing everything from the scratch. But since we already have some of those values, it may just be smarter to use some better formulas. So we can say that the combined mean, which I want to call X. Okay, I can just call that X bar because we already have X1 and X2 bar. So the combined mean X bar is calculated using this nice formula. So the other option you have is to do everything we've done again from the scratch, put using all the numbers together. But here we can just have N1 X1 bar plus N2 X2 bar, since we already have those, so we don't have to start from the scratch. So we have N1 plus N2. So we just need to bring back all those values and use them. So for instance, N1 is 6, right? X1 bar, I remember X1 bar is let's use the decimal already so we don't have to stress ourselves. X1 bar is 6.33. That's 6.33. So X1 bar is 6.33. Then we have what else is there to know? We need N2. N2 is 5 because the second set S2 has 5 numbers. And then X2 bar is simply 6. I think that's all we need so that the X bar now, so we can say therefore X bar is equal to N1. N1 is 6 times X1 bar. Okay, well, allow me to use 19 over 3. I keep getting tempted. I'm seeing a prospect for 19 over 3 here. So 19 over 3 should go because we are going to have a neat result with this, plus N2, which is 5, into X2 bar. X2 bar is 6 divided by N1 plus N2, that's 5 plus 6. Okay, this is looking good. So X bar now, which is overall mean, is 3 here is 1, 3 here is 2. So you can have 2 times 19, that's 38, plus 5 times 6, that's 30, divided by 5 plus 6, which is 11. Okay. I think everything is in order. So that X bar now is 68 divided by 11. 68 divided by 11. So X bar, that's the combined mean, is 68 over 11. That should be 6 point something. That's 6 whole number, 2 over 11. So let's just do that. 68 divided by 11. So that is 6. 6, all right, 6.18. I can just leave it at 6.18. So that is the combined mean. Okay. So you can say therefore the combined mean is X bar equals 6.18. What you should have just done is add everything together and you divide by 11. That's exactly what you're still going to get if you do that. Okay. Because yeah, that's exactly what you're still going to get. Because here now for the mean, to be sure, this is 30, interesting, and this is 38. So that works perfectly. Works perfectly, especially if I use the fraction without losing any value there. Okay, so the next thing we want to do is to find the standard deviation for the combined sets S1 and S2. Interestingly, instead of having to do it from the scratch, we can just also use the values we already have. So let's see how that works. Um, okay. To find the combined standard deviation. Okay. We have we have so we can say now we have SD, just SD, and that will be square root of n1 minus 1 s1 squared. I mean, that's, let me call it n1 minus 1, right? SD1 squared, since we called it SD1 squared plus n2. This is going to be serious. So n2 minus 1 SD2 squared plus n1 into x1 bar minus x bar all squared. Interesting. Plus n2 into x2 bar minus x bar squared. All of this now divided by n1 plus n2 minus 1. Well, if you feel this formula is too much, you may just do everything from the scratch. Just do the normal standard deviation that you know. But I think it's also good to be introduced to some new idea. So you have n1 minus 1, standard deviation 1 squared plus n2 minus 1, standard deviation 2 squared plus n1 into the mean for the first set minus overall mean all squared plus n2 times mean for the second set minus the overall sets all raised to the power 2. So let's not forget again. Let's bring all the values we have known. N1 is 6. Then what do we need next? SD1. What is SD1 again? We can quickly check up that. SD1 is 3.141. SD1 is 3.141. Or we can just say 3.14 if everything is to two decimal places. Then what do we need again? We need N2. N2 is 5. And SD2 is SD2 is 1.87. SD2 is 1.87. What else do we need? We need X1 bar. X1 bar is 6.33. That's 19 over 3. And X2 bar is 6. Whereas X bar overall, X is 6.18. That's what we just got there. I think that's all we need. Yeah, that's about all we need. So we can go for that. Can I say therefore SD is equal to square root of, let's go, n1 minus 1, that is 6 minus 1, into SD1 squared, that's 3.14 all squared, plus n2, which is 5 minus 1, times SD2. SD2 is 1.87 squared, okay, plus n1. N1 is 6 into x1 bar. X1 bar is 6.33 minus 6.18 squared, okay? Then plus N2. N2 is 5 into x2 bar. X2 bar is 6 minus x bar, that's 6.18 all squared, divided by n1 plus n2 minus 1. That's 6 plus 5 minus 1. So the overall standard deviation is now square root of 5 times 3.14 all squared, 3, 3.14. So 3.14 raised to power 2 is equal to 9.8596. We have that then 4 into 1.87 raised to power 2, 1.87. So that is 3.4969 plus 6 into, let's just do that straight to save time. So we just have 6.33 minus 6.18 all squared. That is like 6.33 minus 6.18 squared. That's 0.0225 like this, plus 5 into 6 minus 6.18. That's just 6 minus 6.18 squared. That is 0.0324. All that over 6 plus 5 is 11 minus 1, that's 10. Okay, things are getting tidier, I believe. So that SD is equal to square root of, I mean, if you have your way, you can avoid this kind of question. Sure thing. Sometimes it's smarter to choose questions that are not this demanding if you have options. So 9.8596, 9.8596, 5 times 9.8596, that's 49.298 plus the next thing is 5.89, Okay. So next we have 4 times 3.4969, 3.4969. 4 times 3.4969. That is 13. I'm trying to be sure. Yeah, 13.9876. And 6 times all that. That's 6 times 0.0225. 6 times 0.0225. That is 0.135 plus 5 times 0.0324. 5 times 0.0324. That is 0.162 all over 10. So that SD now is equal to square root of now let's go. We have 49.298 plus 13.9876. 49.298 plus 13.9876 plus 0.135 plus 0.162. So 0.162. 49.298 plus 13.9876 plus 0.135 plus 0.162. All that is 63.5826 divided by 10. So the standard deviation now is square root of 6.35826. 6.35826. So let's take the square root of that. So square root of 6.35826. Square root of 6.35826. And that means that the standard deviation is 2.52. Standard deviation. So we say the combined standard deviation. Therefore, the combined standard deviation is 2.52. So with that, I guess we are done with the first part of the question. The second part is just to explain type 1 and type 2 errors, which I've done in a previous video, but let's do it again. That's the B part of this question. That's the easier part, so to speak. So let's talk about all that. Okay. All right. So let's talk about type 1 and type 2 errors. So starting with type 1 error, right? Type 1 error. Type 1 error. So this occurs when a true null hypothesis, is incorrectly rejected. It is also known as a false positive. False positive. So rejecting the right, that's type 1 error. When you reject the right null hypothesis, it's error type 1. Or you can say it's called false positive, or an error of the first kind. An error of the first kind. Rejecting the right null hypothesis is an error of the first kind. So the probability of making a type 1 error, is denoted by alpha, which is the significance level, of the test. Okay, so that is type 1 error. Let's talk about type 2 error. Type 2 error. Okay, I thought I was changing that. So type 2 error. Okay, this occurs when a false when a false uh, this occurs when a false null hypothesis is not rejected. So type 1 error rejecting the right, type 2 error accepting the wrong. So type 2 error occurs when a false null hypothesis is not rejected. So you accept the wrong thing. So this is referred to as a false negative. It's a false negative accepting the wrong. It's a false negative. So, okay, or an error, it's an error of the second kind. An error of the second kind. Okay. So the probability of making a type 2 error is denoted by beta, and 1 minus beta represents the power of the test. So if you want to find the power of the test, then you get 1 minus beta. So generally speaking, right? Generally, in hypothesis testing, minimizing minimizing both type 1 and type 2 errors is crucial for is crucial is crucial for accurate conclusions. All right. So with that, we come to the end of this nice video. So if you have not subscribed, be sure to do that. Hit the notification bell so you can always get notified each time a new video is released. Then comment, tell me if you want to just to treat a topic or answer a question. Also like, then you want to share with others so that more people can uh learn these things. Till later, till I see you again, have a great time. Bye.